Welcome to clickmyproject.com. Let's discuss on the title Emotion Recognition from Multimodal Information. Emotions are important in human intelligence, rational decision making, social interpretation, perception, learning, memory, and more. Intact perception and experience of emotion is vital for communication in social environment. Accordingly, understanding emotions is indispensable for the day-to-day functioning of human. Technologies for processing daily activities, including facial expression, speech, and language, have expanded the interaction modalities between humans and computer-supported communicational artifacts such as robots, iPad, and mobile phone. With the growing and varied uses of human-computer interactions, emotion recognition technology provides an opportunity to promote harmonious interactions or communication between computers and humans. Perception and production of emotional expression are central to verbal or non-verbal communication. Hence, constructing an emotion recognition system from multimodal information is desirable. Speech is another one of the most important and natural channels to transmit human affective states, especially on verbal communication. Affective cues can convey the most important aspect of what is said, such as whether the speaker likes something or not. Affective information in speech can be transmitted through explicit, that is linguistic, and implicit, paralinguistic messages during communication. The former can be understood and extracted from affective words, phrases, sentences, semantic content, and more, and the latter may be explored from the prosodic and acoustic information of speech. Similar to facial expression analysis, most of the speech emotion recognition studies are focused on recognizing the six prototypical emotional states. In addition, some of the non-prototypical emotions were also explored, such as frustration, puzzle, and bore based on the linguistic information or non-linguistic vocalization. However, these emotions only represent a small set of human affective states and are unable to capture the subtle affective changes that humans exhibit in everyday interaction. Let's have the discussion on the data flow diagram. Regarding the data flow diagram, the voice signals are converted to frames. For example, here 40 frames have been converted. Frames are nothing but segments of a signal that is subjected to feature extraction such as pitch, MFCC, energy, and somewhat. And those features are subjected to statistical measures. These statistical measures are given to KNN classifier for training the signal depending upon the expression. And in order to recognize the expression, select a test voice signal, do all the frame conversion techniques, and then extract the features, compute the same statistical measures, and give that as a feature vector to the KNN classifier. Then you will get the recognized expression. Regarding execution of the program, select main file and press run file. You have to select an expression from the data set shown. Select any one of the MP3 file. This is the execution of the substrum of a signal, which is called as feature. After the feature is completed, the classifier executes and the expression will be recognized as an angry expression. This is the input signal representing anger expression, and this is the frame conversion. The signal is separated into 40 segments, and third one is the substrum. Spectrum of a spectrum is called as substrum, and this will calculate the features along with other features which are stored in mat file, and this is the finally contained expression in the signal selector. This is the classification parameter. This paper provided a survey of current research work in audio-visual and also the emotion-based recognition. The theoretical background applications ranging from salient emotional features to multimodal data have been studied. Although number of promising studies have been proposed successfully applied to various applications, there are still some important issues yet to be addressed in the fields include the following. Towards spontaneous emotional expression analysis, how to build a comprehensive and accessible benchmark database is indispensable. And exploring the issues on the effects of a person's arbitrary movement, partial occlusion, speaking, complex temporal course of emotional expression, and background noise is beneficial to increase the system value in real-time application. A better anatomic feature normalization approach should be considered and developed in future. Since most of the studies assume the speaker ID are known and have neutral examples for each speaker beforehand, modeling the context information, that is simultaneously considering the sub-emotional onset and emotional state transition within utterances, is useful in spontaneous emotion approach analysis. Developing a better data fusion approach is desirable to obtain advantages of various fusion strategies, such as combining model level and decision level fusion properties. Thank you.